Okay,
Wolfgang,
thank
floor
you,
is yours.
Valeria. You see, it's quite exotic and different from what we heard all these last 3 days, but I just wanted to share some of the ideas on teaching biotremology in general and teaching it under these difficult conditions that we were faced with for the last 2.5 years. So the pandemic caused quite a lot of adaptations all over the world for the last 2.5 years, including conferences which had to be postponed. And in the universities, we were faced with a situation that our students had to stay at home for a while in Europe, in many countries, for many weeks actually. And we had somehow to learn how to distance teach them, which is possible, of course, if it comes to lectures and seminars, but it's a real problem in science where we usually want to have practical classes. We want to teach them to actually do things and to analyze data, to test hypotheses and so on. So and in this situation, what I did and want to share with you was that I invented something which I called Home Lab, and that's that my students were provided with equipment for doing experiments at home. They were supervised in Zoom sessions, and we were able to apply that to nearly everything what we are doing, to entomology classes on dissection of insects, looking at microscopic slides, collection, identification, preservation of insect specimen, but also projects on insect behavior, like orientation and communication, which seems to be quite impossible on the first glance, but it was possible. And communication in our case is acoustical and vibrational communication, and I would just like to tell you how we are doing that. While we have seen equipment used in our field for research purposes quite a lot during the past days, starting with vibration exciters, like the Brüel-Kjær 4810 that nearly everybody here seems to use, and other equipment, typical equipment for research purposes when you want to do playback experiments, and playback experiments is probably the only experiment that you can do with classes of numbers of students. You can't provide each of them with a laser vibrometer to record things, but playback experiments are possible. But then you still have the problem that equipment is expensive. So standard equipment, state-of-the-art equipment for playback is probably in the range of 20,000 euros per setup. So fortunately enough, I started at least 10 years ago to scale that down for teaching biotremology in classes. And I just want to share with you some lower cost alternatives for the equipment. The nice Brüel-Kjær vibration exciter can well be replaced by low-cost stuff like the one that we are building in our workshop, faculty workshop, based on this VisaTone loudspeaker, which is basically doing the same job and has a good frequency response, good enough for, at least for teaching purposes, I would say for all purposes, quite linear and flat. So that helps a lot. This way. That's what it looks like. It's just this little loudspeaker put into a box. There are also commercially available solutions, but they are worse. This one, for example, even cheaper, is much worse in the frequency response, but the other one is good. So power amplifiers are no problem because nearly all of the signals that we are studying here are in the audio frequency range, and therefore people who want to listen to music, of course, have also do also want to see some quality and frequency responses. So usually consumer audio power amplifiers are good for nearly everything that we want to do. Accelerometers, well, I really like the Brüel-Kjær ones, but They are clones of these which are just identical. Metra is an Eastern German company. They produced clones of Brüel-Kjær stuff already in communist times, and they just identically reproduce them, and they are, I can recommend them. They are reliable, they are nearly identical in their properties, but much cheaper. Well, something that most of us probably like very much is the Brüel-Kjær charge amplifier because of its really impressive properties, but it can also be replaced by other equipment of lower cost. There is an amplifier, this one here, which is nearly as good. And then I found relatively recently one which is extremely small in size, and it comes to frequency response and internal noises, so is absolutely as good as a Brüel-Kjær one, and portable and lightweight, and something I really like, not only for playback, but also for recording. So our typical recording instrumentation in the field is recorders, either Tascam or Zoom, that we have seen several times here during the past days. And then we just use these little amplifiers driven through the phantom power supply and an adapter, changing it into IEPE. So making it really very portable and also affordable to record and do even 4 channels in the field. So we basically, for classroom experiments, we had equipment in which we scaled down the expensive already by a factor of 10 compared to the typical research setup. But 2,000 euro is still too much, of course, to provide students with this kind of equipment and to take it at home for days or weeks and work with it. So the task was to scale it down a little bit further, and so that's what we use in classes typically. There's typically students are in groups of 2. One is looking at thresholds of perception, either human, so just in the fingertip, or insect perception. The other one is providing the stimuli, setting frequencies and amplitudes, and then with the switch either delivering stimulus just into the loudspeaker, so that's the sham stimulus, or in addition into the vibration exciter. So that's what we're doing in the classroom. And then for doing it at home, the challenges were threefold. Expenses still too high, and well, I really like to use oscilloscopes because the concept of what we need to do when we are controlling signals can be explained very well when you're usually actually use an oscilloscope, although nowadays oscilloscopes are just simulations, of course, of oscilloscopes, so they are basically computers. But it's difficult to supervise people via online tools in how to use the oscilloscope once they have lost the track. It's difficult. So that's also a problem. And we like blinded experiments. The student watching something, an insect or doing the experiment, should not know whether there's signal, stimulus or sham stimulus. So that's the 3 challenges. For playback, we had already some low-cost stuff, so low-cost vibration exciters and the low-cost amplifiers. And of course, we do not really need waveform generators. If we just record waveforms, any instrument that plays back wave files is then fine for playback experiments at home. So, or even the other low-cost exciter. So playback is not the problem, but of course the output of the smartphone, tablet, or anything else, and an audio amplifier, the output is not calibrated in amplitudes, and therefore you need to do something. Well, our solution was to provide them just with a digital voltmeter, and calibrate the output of the exciter so that they then just know what at certain frequencies the transmission factor is of the system. You can also actually see that these vibration excitators are really quite linear, so these differences don't mean anything for my taste. But we calibrated them. So this allows them to do calibrated experiments and scale the expenses down by another factor of 10, and then it comes into range where you can buy and build the equipment for a number of students, third-year classes of 20 students or something like this. So that's what it looks like. Signal is generated in a computer. One channel goes into the earphones, the other channel goes through an amplifier into the vibration exciter, and amplitudes are controlled using the digital voltmeter. It's also solves the problem that the oscilloscope is not easy to explain over the internet. It's just a digital voltmeter, simple to use. And it also allows to do blinded playback experiments. And we did that with long series of wave files, which just had numbers. And some of them had two stereo channels. One was a stimulus, the other one for the earphones, and others had just the channel which was played back through the earphones. And the students got the list of file numbers afterwards, and then they could check whether something was a stimulus or sham stimulus. So it worked, it fulfilled the needs that we had. Yeah, that's what it, again, what it looks like. Blinded experiments are then possible. And well, just examples of results that students got at home. For example, thresholds of the human sense of vibrations in the fingertip. They just got to what we expect and what we find in the literature, something like 1 micrometer in displacement amplitude. And they were provided with crickets that they studied at home for a couple of days. And so these same 10 students had something like 77 crickets that they studied and came also to expected thresholds of perception. And so it's well possible to do this kind of work in what I call the home lab, and students had fun and it was possible to supervise them. So distance learning is possible in experimental classes, and for the case that we will have more pandemics, civil wars, nuclear power plant explosions or things like that, I can recommend to let them do experiments at home, and that's also possible for biotremology classes. And well, but I also must say, however, it's of course not really the same when students learn at home, and we worked a little bit on it, not in a biotremological class, but in a class on something else, which was a microscopy lab, and we looked at not only learning effects, but also emotional effects in the class, measuring things like heart rate variability, which is a measure of arousal, and saliva cortisol levels with online formats and face-to-face learning. And it showed that compared to students just staying at home, doing nothing in the control conditions, the emotional effects of being in the classroom, doing the experiment there, compared to doing it at home, was stronger. So it is not the same, but it's better than nothing. But it cannot fully replace, of course, the classroom. And that's probably not only true for our students, but for all of us. And therefore, I really think we should thank the organizers for not giving up and making a face-to-face meeting here happen, which I enjoyed very much, I must say. Okay, thanks.